discussion for experiment 3, which is studying of the LeChateliers principle. What is LeChateliers principle? LeChateliers principle applies to a reaction at equilibrium. So you need to know what is equilibrium. Equilibrium or dynamic equilibrium is when a reaction, so when you have a reaction that reaches equilibrium, that means the rate, first of all, the reaction must be reversible. So we have a double arrow here. And the rate of the forward reaction is going to equal to the rate of the reverse reaction. So reaction is reversible. When it does reach equilibrium, the rate is going to be the same. Or rate for the forward reaction is going to be equal to the rate for the reverse reaction. Rate forward, rate reverse is going to be equal. And then you have equilibrium. Based on LeChateliers principle, it says when you have a system at equilibrium, you have a system at equilibrium and external pressure is applied to the system at equilibrium, the equilibrium is going to shift. That means reactants can go to product side, products can go to the reactant side until we get that equilibrium constant again maintained. The equilibrium constant, K equilibrium, is concentration of the product. Okay, concentration of product. So if I have a lowercase c, lowercase d, a, and a b, so it's going to be to the power of CD over concentration of the reactants. Okay, that's the equilibrium expression. Concentration of product raised to the power of their coefficient, concentration of the reactants raised to the power of the coefficient. Solids and liquids are not allowed. So if you have water is liquid, the concentration stays constant. It's not going to be part of the equilibrium. If you have a solid that is forming, is not going to be part of the equilibrium. So this is just for compounds that they are in aqueous solution. And if you're dealing with gas samples, then you could use the pressure of the gas or concentration of the gas, but solids and liquids are not allowed. So when you have a reaction at equilibrium, you can change, if you change the concentration, equilibrium is going to shift. If you increase the reactant, in order to maintain the value for Ke, you need more products in order for this ratio to stay constant. So the reaction is going to move forward and in order to make more products. So this ratio is going to stay constant. If you decrease the reactant, so you have less reactant, if the product stays the same, then this ratio is going to be higher than what it was before. And in order to maintain that equilibrium, is going to shift to the left side. That means more reactant needs to be formed in order for the K equilibrium to maintain. So if you increase the product, what's going to happen? That means you're adding more C. If this reaction is already at equilibrium, you externally, you just bring more C and you add more C. That means you are increasing concentration of the product. If you add more C, then you get high concentration of the product. So the reaction has to shift to left side for the reactant to form in order to keep this ratio constant. That's one factor. You can change the concentration, the equilibrium is going to shift. The other factor that you could change for equilibrium to shift is going to be a temperature factor. So when you have temperature in effect, when would you have a temperature affecting? if you know already that reaction is exothermic or endothermic. Let's say if this reaction is exothermic, that means that heat is going to be produced. So this is the exothermic reaction. If the reaction is exothermic reaction, if you increase the temperature, what's going to happen if you increase the temperature? That means you're adding heat. If you add heat, you're adding more product. So this reaction is going to go to the reactant side. So it's going to go to the left. This is for exothermic reaction. If you have endothermic reaction, if you have A plus B plus heat, that gives product, C plus D. Okay, this is an endothermic reaction. So heat is one of the reactants. So you would treat heat just like one of the reactants. So you say, if I increase the heat, I'm putting more reactants. So this reaction must go to the product side to give me more product. So the K equilibrium does not change. So you have to treat the heat. Basically, it has to be like a limited heat that you are applying just to see the change. So the reaction is going to shift in a way that would consume heat. If it's endothermic, consuming heat would go to product because heat is reactant, would form product. If it's exothermic, consuming of the heat, meaning using product, so the reaction is going to produce more reactant. In this experiment, we have 4 different reactions which you are going to study. The LeChateliers principle, you have a reaction of the cobalt chloride in aqueous solution. Cobalt chloride in aqueous solution is going to be light pink color. And if you add chloride ion, at a high concentration of chloride ion is going to form, chloride is going to replace the water and is going to give this dark blue color. So it goes from pink color to the blue color. So there would be color change. What you need to do, first of all, to look at the given reaction. This reaction is the endothermic reaction. So if you add heat, the reaction is going to go to product side. What is indication that the product side has formed is the color of blue. If it turns blue, that means it went to the product side. So when you are writing your observation, please do not say that turn blue or turn pink, because that's not a 1046, analysis of or recording observation. We are studying LeChateliers principle. We are trying to see the change in concentration of a reactant or product. How did it affect the equilibrium? Did the equilibrium shift to the right side to form more product, or did it shift to the left side to form more reactant? And please explain what is happening. In the reaction of mixture of acetic acid and sodium acetate, this is an equilibrium of a buffer solution because we have a weak acid and the salt of the weak acid. We are studying the buffer using LeChateliers principle, which kind of adds another layer to this experiment, which is good because then you can see actually how buffer resists changing pH. So if you had limited amount of acid or base to a buffer solution, the pH will not change significantly. But if you add strong base or strong acid, even limited amount to water, the pH is going to change significantly. So we are going to study the equilibrium by adding small quantity of HCl or sodium hydroxide. You have to look at the pH and see what happened to the pH. For the pH, you have choices. You can use universal indicator. You could use pH meter, which that's what I used in your experiment. I used pH meter and is more accurate. And you could also use universal indicator. If the color doesn't change, or if it changes, like what is the next color, as long as the pH doesn't change significantly, still is going to show the effect of the buffer system, like how buffer works. Next reaction would be chromate solution. If you acidify chromate solution, so you have a chromate solution that is a yellow color, you add more acid, it will change to dichromate, which is orange color. So please don't say change it yellow color to orange color, or orange color appeared or disappeared. Refer that to as the reactant site or product site, and shift of equilibrium to the reactant site, or producing more product or more reactant, what you see that is happening, okay? Like in this experiment, when you have this chloride ion for the cobalt chloride, what happens if you add silver ion? If you add silver ion is going to react with chloride ion and is going to get silver chloride solid. It brings the silver chloride ion out of the solution. That means you are lowering concentration of the chloride ion. Just pay attention to that. Okay. For this one, if you add hydroxide ion, what will happen? If you add hydroxide ion will react with this. It's going to change to H2O. H2O is liquid. So at the equilibrium, you don't use the H2O. So basically concentration of H plus is going to go down. And if it goes down, the reaction would go to the left side. Pay attention to chemical reaction and refer to chemical reaction in order to answer the question. The last reaction is going to be the iron 3 thiocyanate solution, which you are going to make this solution first. And then you are going to add reactant, add product, add heat, and look for the effect. So you are looking for the cause and the effect. The changes, if it changes to pale yellow color, that means that it went to the equilibrium shift to the reactant side. If it gives more deep red color, means the equilibrium shift to the product side. So please write your observation more using more of a scientific term about the chemical equilibrium and the LeChatelier's principle.